Question B3. Choose an external wall construction including internal and external cladding suited to a panel or platform type timber frame house, and at a 1 to 5 scale draw a section through the construction and annotate to describe structural performance, thermal performance, performance in relationship to the exclusion of rainwater, and performance related to the exclusion of decay due to condensation. Here in this sketch I've actually shown the construction in perspective, but primarily we've got the principal elements of the actual construction itself. We've got the vertical timber studs which provide the structural support, and they sit on a sequence of soil plate and bottom plate to actually form the actual sort of bottom of the structure. In terms of the other structural element, outside the actual structural frame here you'll actually have a sheet of material, usually a sheet of plywood or OSB board, which provides a sort of a rigid connection to the frame to stop it from sort of moving from side to side. Now because it's actually got a cavity wall construction, we've got a sequence of wall ties that are actually connected to the timber studs, and then these actually penetrate across the cavity and brace the actual wall itself. In terms of thermal performance, the space between the studs is actually filled with insulation, and if you want to have extra performance we can actually sort of widen the gap. We can actually, perhaps instead of using sort of rectangular section timber, we can use I-section timber, and we can also put insulation on the outside of the frame as well, warm frame construction. If we want to prevent the ingress of rainwater, on the outside of the cladding system we've got a breather paper which is waterproof but lets water vapour pass through. Where any of the structure might touch the outer leaf, because the outer leaf is going to be quite wet, we're going to actually wrap around a damp proof membrane around any closures to the cavity and any sort of battens for actual sort of the window fixing around the cavity itself. In terms of internal decay, that's prevented by actually having a vapour barrier, and the vapour barrier here is on the inside of the construction, just inside the plasterboard finish, and that prevents any water vapour from the inside the space transferring across and condensing on the colder plywood surface. Here I've just got some variants on the cladding system. The previous cladding system was masonry. All the same apply, except here we've got vertical timber boards, and we need two sets of battens. The first batten is a vertical batten that sort of lines up with the stud itself, and then a horizontal batten. The purpose of having two battens, and usually this batten is actually sort of it's got an edge that actually slopes away, and here is that we need to actually make sure that we've got a cavity behind, so that any rainwater doesn't actually lie on top of this batten but drains off the back of the batten and down through the cavity and out of the construction. Again, in this example here we've got tiles attached to the actual slates, actually attached to the actual sort of battens themselves, and again we'd probably need to actually have vertical battens behind here just to make sure that any rainwater that did get behind was actually sort of removed. Another couple of variations on the theme here, we've got a cement rendered finish, and that's actually attached to a batten, and the batten is actually sort of a treated batten that's actually attached to the studs with a DPC between the batten and the cement board. On this example here we've got horizontal boarding, so instead of having a vertical and horizontal batten, all we need is just a vertical batten to actually sort of provide a cavity so that any water that gets behind here can't get past the breather membrane, drains down through the bottom of the cavity.